Hello. In this video, we'll be talking about separations of solutions and mixtures using chromatography, as the title says, but we'll also be talking about distillation. One important thing to remember about solutions is that when you have some solute dissolved in a solvent, a solution cannot be separated by filtration. The particles are entirely too small since solutions are combined on a particle level, and there's not any macroscopic particles to separate using filter paper. So solutions cannot be separated by filtration. So we're going to look at two different ways that solutions can be separated. The first one I'm going to talk about is distillation, and then I'm going to talk about chromatography. So let's first talk about distillation. So in distillation, you have a solution where you have a solute dissolved in a solvent, and we're going to assume that our solvent is water. And then we're going to have some other polar substance dissolved in the water. And I'm going to represent the polar substance just using kind of a diagram like this, where one side of this molecule is negative and one side of this molecule is positive. And of course, the positive sides are attracted to the negative sides of the water molecule, and the negative sides are attracted to the positive sides of the water molecule. So there are intermolecular forces that are holding together these polar molecules, the water molecules and the polar solute. And those interactions are what keep the solute dissolved in the solvent. However, the strength of the force between the water molecules and the solute is different than the strength of the force that water would have on itself. Remember, water has hydrogen bonds with itself and has a dipole-dipole force with whatever is being dissolved in here, more than likely. It could be hydrogen bonding if the substance that's being dissolved has an OH, an NH, or an FH. But it's a intermolecular force that's holding the water and the solute together. The strength of the intermolecular forces could be weaker or stronger between the solute and solvent than the water has for itself. And so the question is, which intermolecular forces are the weakest? Well, if we add heat to this, the weakest intermolecular force, that's supposed to be fire. I don't know why that's supposed to be fire, but anyway, that's fire. So anyway, if we heat this beaker up, the weakest intermolecular forces are going to break first, and the stronger intermolecular forces are going to stay attracted to each other. Distillation takes advantage of this. In distillation, you add heat to your solution. So heat is added to the solution. The substance with the weakest intermolecular forces is going to boil off. We collect that in a sealed container, except that there is a tube off to the side called a condenser. And so the substance with the weaker intermolecular forces is going to go up into this column. It's going to go down through the condenser and go from the gas phase, condense back to its liquid phase, and then it's going to condense out into a side container over here. The substance with the strong intermolecular forces will stay behind as a liquid. The substance with the weaker intermolecular forces will go up as a gas. And then once the substance with the weaker intermolecular forces completely is removed from that solution, then the second substance can start boiling off. And so distillation is simply a way of separating substances that have stronger and weaker intermolecular forces, with the substance with the weaker intermolecular forces boiling off first, and the substance with the stronger intermolecular forces boiling off next. This is a very crude diagram, but it gives you the idea of what distillation is and how it works. It works by differing intermolecular forces. The second type of separation technique we're going to look at is chromatography, which relies on intermolecular forces. A lot of times you'll have different components in a mixture that you want to have separated out, or you want to know how much of each substance is in a mixture. And so chromatography allows us to do that. So we're going to look at just the basics today. We're not going to go in large detail about chromatography, but we're going to look at just what the basics are to chromatography. So chromatography is a separation technique that relies on the strength of intermolecular forces to separate the components of a mixture. There's two parts to chromatography that have different intermolecular forces. A mobile phase, which is either more or less polar than a stationary phase. The mobile phase, as its name implies, moves, whereas the stationary phase stays still. And so the mobile phase will carry a mixture through a stationary phase, and the components of that mixture will either be more attracted to the mobile phase or more attracted to the stationary phase. There are 4 different types of chromatography, and we're not going to go into the detail of each one. We're going to look at paper chromatography, but then next week we'll look at liquid chromatography. So, like I said, the mobile phase is a phase that moves, and it carries the components of a mixture through a stationary phase. And some of those components in the mixture, some of the parts of the mixture will be more attracted to the mobile phase, and some of the parts of the mixture will be more attracted to the stationary phase. The stationary phase is the surface that the mobile phase travels through. And again, the mobile and stationary phase have different polarities, and so the components of the mixture are going to be attracted to either the mobile phase or the stationary phase to different degrees. So in this animation that I have here, the components of I'm going to redo it in a second, but the components of the mixture are the red and green dots that are mixed together, and they start on the left-hand side. The mobile phase is not, you can't see it in this animation, but the mobile phase is a liquid or gas that moves through the animation from left to right. The black represents a tube or the solid that the mobile phase is moving through. And then the blue-black dots represent the stationary phase. They are just the large particles that the green and red mixture have to pass through. In this particular animation, the red parts of the mixture are more attracted to the stationary phase. The green components of the mixture are more attracted to the mobile phase. So I'm going to restart this animation and we'll see this again. So there's the components. They're moving from left to right. The mobile phase is carrying them from left to right. But notice the red dots got kind of hung up. And that's because they were more attracted to the blue and black stationary phase, and the green dots were more attracted to the mobile phase. I'm going to restart this animation one more time, and you can see it in action again. So the mobile phase moves left to right, carrying the green and red dots, but the red dots are more attracted to the stationary phase than the green dots are, meaning the green component gets carried out first at the end of this chromatography. The red dots will come out later. So let's just see this in what's called paper chromatography. If you have a mixture, like different types of ink that we want to separate, see what's in those different types of ink, we can put the ink or the mixture onto a piece of paper. And so I have that drawn down here. The line represents the starting point of these 4 different inks. The paper is then placed in a liquid solvent, and this liquid solvent's the mobile phase. It's going to, through capillary action, be drawn up through the paper, which is then going to hit these 4 different inks that I have on the piece of paper. And as the mobile phase goes up, it's going to attract the inks in these 4 different mixtures. The mobile phase will move up and it will pull on those inks, but the inks will have different attraction to the paper also, the stationary phase. So if you look over here, this is the after result of this paper chromatography. And you'll notice the blue was more attracted to the mobile phase because it went up the farthest. The red here was less attracted to the mobile phase, but still pretty attracted. It went up pretty far. This aqua dot didn't go up as far. It was about halfway up, meaning that it was more attracted to the paper than it was to the mobile phase. And this last dot actually has different components in it. You'll notice there's red and there's black, meaning that in this ink, there were 2 different pigments. There was a black pigment that was more attracted to the paper, which is the stationary phase, and there's the red component that was more attracted to the mobile phase and got drawn up farther. So in the next slide, we're going to see an actual chromatogram, an actual chromatography result. So here is what's called the solvent front, which is how far the solvent went up the paper. And then here are the different dots of the ink that were put on the paper. And as the mobile phase went up, it drew out the different components of the ink. So the ink in this one had 3 different colors. It had a red color, a purple color, a blue color that were mixed together to make the color of ink that that particular dot had in it. And then you can see each of these different inks had different components. This one had kind of a red and a yellow component, red and a yellow component. This one seems to have green and maybe a yellow component. And then you can see that each ink had different components in the ink to make the color of ink that was in the pen. So that is paper chromatography. This particular chromatography is not very quantitative. In other words, we can't see how much of each of these inks were in, or components were in the ink that was the original mixture. We can just see that there were different colors. So this is a much more qualitative chromatography. We're not going to go into all the different types of chromatography. We're just going to stop here because I just wanted you to understand kind of qualitatively what is chromatography. We're going to talk about it in a little more detail when we do our lab on liquid chromatography. But again, the whole concept is there's a mobile phase and a solid phase. In this case, the solvent and the paper. And the components of a mixture are more or less attracted to the solvent or the paper based on their polarities. So that's where we're going to stop.